The next important topic, Pythagoras theorem. We learned about Pythagoras theorem in the lower class itself only. The same thing only. Now we are using as a geometrical proof for proving the theorem. In a right triangle, the square of the hypotenuse is equal to sum of the square of the other two sides. So a right triangle is given, the square of the hypotenuse that is equal to the sum of the square of the other two sides. Normal theorem only. How to do this one? What is given in the question? A right triangle ABC, right angle to B, that means angle B equal to 90 degree. If angle B is 90 degree, AC is the hypotenuse, then according to theorem, we have to prove that AC square equal to AB square plus BC square. We have to draw the perpendicular now. Draw BD perpendicular to AC. Now the bigger triangle ABC we are taking and the smaller one ABD we are taking. So ABD is here and the ABC is the bigger one only. So in triangle ABC, angle B equal to 90, and similarly in triangle ADB, if you consider, angle D is equal to 90 degree, right? So we got a 90 degree here. So we can write that angle D is equal to 90 degree here. Okay. Next. So both the angle we got as a 90 degree first. Then what is that one more common angle we required? So already we have seen that ABD angle A is coming, right? Next, similarly, angle triangle ABC also angle A coming. So we got two angles here. So triangle ABC similar to triangle ABD by AA criteria. If we have written AA criteria, then the result what we can write AB by AC equal to AD by AB. AB we have written because we need AB square to prove AC square equal to AB square. So whatever is required, that only we have written. One more side also, as you know that we can write it, it's not written. So what we have got here, AB square equal to AD into AC. Similarly, triangle ABC we are taking, but this time we are going to take which one? Triangle BCD, the smaller triangle. Now as you check the figure, we know that angle D is 90 degree, the C equal to 90 degree, as well as angle B in bigger triangle ABC. But which is the common angle? Angle C is the common. So similar way, 190 degree we got, one common angle we got. So we got that triangle ABC similar to triangle BCD. What is the next criteria? We have to write the sides we should take down. Now this time we need BC square. Go for this one. So AB square we got. Now we need BC square only. So what we should write, BC square equal to DC into AC. According to that, the side we have written. Now for the first equation and the second equation, if we add, what is the criteria we will get? AB square plus BC square on the left hand side, AD into AC plus DC into AC only. What we are doing here, equation 1 and equation 2 we are adding. So we got the equations 1 and 2. Now what is the result? We are getting AB square plus BC square equal to AD into AC plus DC into AC. So what is common on the right hand side? AC is common. Now what we are writing in the bracket? AD plus DC. Now we will go back the diagram and check that. What is AD plus DC? AD plus DC is AC only, right? We can see here AD plus DC, it is equal to AC. So AC we are writing here. So we got AC into AC, that means AC square. So it's a normal theorem only. We have used the geometrical proof only, nothing else. So what is the answer? We got AB square plus BC square equal to AC square. That is our Pythagoras theorem. Now it's a your for understanding, for your knowledge, it is given in the textbook that the above theorem was earlier given by ancient Indian mathematician Bodhian in the following form. The diagonal of a rectangle produces by itself the same area produced by its both sides, that is length and a breadth. When you draw a rectangle and join the diagonal, you will get that length and breadth will be the base and height of that right triangle only. So for this reason, this theorem is already sometimes referred to as Baudhian theorem only. That is for knowledge only, nothing else. So if Baudhian theorem is state and prove, means this only we have to do. Now since it is an MCQ pattern, pattern, directly it will not come. You have to get the result only. Now we have proved Pythagoras. Similarly, we have to go for converse Pythagoras theorem. Converse Pythagoras theorem, in a triangle, if a square of one side is equal to sum of the square of the other two sides, then the angle opposite to its first side is a right angle. That means AC square equal to AB square plus BC square is given. Now what we should bring? Angle B equal to 90 degree. Right. Now we have to draw another triangle PQR where angle Q is right angle. We are assuming that angle B is not a right angle. What we are taking, we should prove and bring it that angle B is a 90 degree. What we have done here, triangle PQR we have taken at a Q 90 degree we have constructed, then in a such a way that a PQ and AB should be equal and QR and BC should be equal. Now it may came your mind one doubt that when we are creating that it is a sides are equal, then definitely in a right angle triangle the included angle will be equal only. So for by getting this theorem we are using that one triangle PQR we are making where PQ and AB are equal. Similarly QR and BC are equal. So naturally angle Q and angle B will be equal only. So we are using the same construction whatever told in the textbook. So what is the concept here? Already given that if it is a right triangle, what is the condition? We know that if it is a right triangle, we already know that Pythagoras is applicable, Pythagoras theorem. So PR square equal to PQ square plus QR square. That only written by Pythagoras theorem. PR square equal to PQ square plus QR square. Now by construction what we got here, PQ equal to AB and a QR equal to BC. So it is replaced with the AB square and BC square. So PR equal to AC, AB square plus BC square we got. Then we got that AC square equal to AB square plus BC square. From where we got this second statement, it is given in the question, right? ABC is a triangle where AC square equal to AB square plus BC square, that we are written here. So by using this what we can say, AC square equal to AB square plus BC square. That means from 1, AB square plus BC square is replaced with the PR square. What is the meaning of AC now? AC equal to PR. So in triangle ABC and triangle PQR, already by construction two sides are equal, and now we got the third side is also equal. So by SSS congruency criteria, these two triangles are congruent. So naturally all the angles are equal. So we want which angle? Angle B and angle Q only. Angle Q we made it is a 90 degree. So naturally angle B is also equal to 90 degree. So nothing to worry about the proof because we need the applications only. This proof directly will not be asked in the paper because the pattern is changed, right? So converse theorem statement, we know that when the hypotenuse square equal to sum of the square of the two sides, then naturally the angle opposite to the longest side or AC square, it will be 90 degree only. That is the converse statement. Now let us see the examples or exercise questions we are doing first. Sides of the triangle are given below. um, Determine which of them are right triangles. In case right triangle, if you are getting, write the length of the hypotenuse. So first one is 7 centimeter, 24 centimeter, 25 centimeter. So the two smaller sides we are taken from the given, that is 7 and 24. 7 and 24 square, if you are taken 7 square and 24 square, naturally it is 625, which is equal to 25 square. So it's a Pythagoras theorem is correct here. So if it is correct, what we should add also, length of the hypotenuse, that is equal to 25. Now in the case of 3 and 8 and 6, which is the smaller units there, uh, 3 square and 6 square I should take. So 3 square, okay, wait, I'll do once again. 3 square plus 6 square. So 9 plus 36 equal to 45, which is not equal to 8 square. So it's not satisfying Pythagoras theorem only. Okay. Now 50 centimeter, 80 centimeter, 100 centimeter only. So which is the smaller units there? 50 square and 80 square. If you go for this one, you will get 8,900, which is not the 10 square, 100 square. That is the 10,000. So it's not satisfy the Pythagoras theorem. What is the one more question is there? 13, 12 and 5. So you know that it's a Pythagorean triplet only. So 5 square plus 12 square equal to 25 plus 144, which is equal to 169. That is 13 square. So it's satisfied, and we can say that Pythagoras theorem satisfied here. So the length of the hypotenuse equal to 13 only, right? Now the second question. Triangle PQR is a right angled at P and M is a point on QR such that PM perpendicular to QR. Show that PM square equal to QM into MR. See this type of the questions, that is one angle is 90 degree where we are getting angle P 90 degree, and is also given that PM perpendicular to QR. So there also one more 90 degree we are getting. This type of the question we are getting, you can apply this method, that is this 90 angle P equal to 90 degree, right? So the 90 we are dividing as one part we are taking as a x, means the remaining part of P will be 90 minus x, right? One part we are taking as a x, then the remaining part it is 90 minus x only. So in one triangle we are taking, which triangle we are going to take? A triangle PQM. Triangle PQM, here already 190 is there, then we got a 90 minus x. So what is the remaining one? It is x by angle sum property. How we are getting that one? See, one more time I'll explain. One right angle triangle we are taking, right? It is also 90. This is already 90. We are assuming that this is x. So, and what about this one? 90 minus x. See, here also it is 90 only. So, I'll take this A, B, C. So, angle A we should find out. So, it is how we can find out angle B, 180 minus angle B plus angle C. So, 180 minus 90 minus x plus 90 only. So this 90, 90, 180. So this 180 will get cancelled. Minus into minus, that is x only. Understood this one? So what we have taken here, okay, I'll show once again. Two angles, so you can see that 90 degree only there. So how we can go for the easy method of finding this one? You can go for which one? We can go for the one common angle 190 degree also there, but here it is easy one. That how we can do means angle P, this question it is 90 degree. Here I have taken ABC on, right? So ABC, what I have taken that angle, okay, I'll change this one once again. Okay, one more time I'll show. I'll draw a right triangle. Okay. I have drawn one more 90 degree here. Right? Now here this 90. This time I'm writing here 90 minus x. So here it is x only. Then only 90 will be get minus x and plus x will get cancelled. See, this time I have taken this is x and this is 90 minus x. So one angle is 90. Here it is x. So what is the remaining angle here? 90 means already we know that three angles sum is equal to 180 degree only. Already 190 is gone and x is gone. So 180 minus 90 plus x. 180 minus 90, what is the answer? 90, right? So 90 minus x is the remaining angle. That means here. If you understood this one, this is 90 degree, right? And here it is 90 minus x. So what is the remaining angle? Naturally, it will be x. So what are the criteria we are taking this? One angle is 90. Another angle is 90 minus x, then the third angle will be x only. If you add this one, minus x plus x will get cancelled, 90 plus 90, 180 we will get. So that is the idea we are having. When we are having one angle is 90, other angle is x. then what is the third angle? It will be 90 minus x. If you know this one very well, if it is know this one very well, then we can easily write what is the AA criteria and all very easily for this one, right? Okay, let me see this one. I'll show once again. Okay. So here it is given that in triangle PQR, angle P is 90 degrees. So what I made, angle P I made as a x one side and 90 minus x is the other side. Now we are dividing the triangle PQM. We know that one is 90 minus x, one is 90 degree. Then the remaining angle is x. Similarly, it is x and here 90. So the remaining angle is 90 minus x only. Now we have to prove that PM square equal to QM and a MR, right? So here QM is coming, here MR is coming. So from this is which is the letter is not repeated here P only. So we are able to decide the triangle name from this one. P we are giving to QM as well as P we are giving to MR. So these two triangle we got. How we got it? From the proving part. P we are giving to QM, P we are giving to MR. So PMR we got it. Because M is common in everywhere, right? So M cannot be given anywhere, otherwise it's not a triangle only. So which is not a repeated one we are taking, that is P here. So P we are given to this right hand side two parts. So we are getting what is the name of the triangle? PQM and a PMR. Now we just take down PMR. We are taking down. We already gave the name of the angles. So I'm writing PMR. So angle P, angle M, angle R. So angle P is X only, right? Angle Q equal to, sorry, angle M equal to 90. Angle R equal to 90 minus X. Now these values we should find out in triangle PMQ. So similarly we are getting angle Q90, sorry, angle QX, angle M is 90, angle R is equal to 90 minus X. I hope you understood this one. What we should do, first we will write the triangle whatever we have used, that is triangle PMR, right? So triangle PMR, three angles are there: angle P, angle M, angle R. Angle P equal to X, angle M equal to 90, and angle R equal to 90 minus X. Now similarly we find out the values where X is coming in which triangle PMQ. Where is X is coming? It is Q, right? So Q we have written. Where is 90 is coming? M only. So M we are writing. And 90 minus X is R only. So sorry, 90 minus X is P only. So what we are getting there? PMR equal to QMP, right? So that means triangle PMR similar to triangle QMP by AA criteria. You can write easily. So we need we proved that they are similar. So what is the next step? A sides ratio should be taken down, and we need PM square. So we should identify where PM is coming. See here only. So cross multiplying PM into PM equal to QM into MR. So finally, what is the answer? PM square equal to QM into MR. I think you got the idea now. So here what should do? First it identify the triangle from here. We identified PQM, PMR. What is the next step? First I have written PMR. So I have written P, angle M, angle R values x 90, 90 minus x. Now these values we are finding out the other triangle QMP. Now we have written in the order and we have written the criteria, then written down the sides ratio. So what is that one? We required one we are getting. Now the third question you can understand easily. Okay. Third question. ABD is a triangle right angled at A. AC perpendicular to BD. Show that AB square equal to BC into BD and AC square. Three questions are there. It is already given that A is 90 degree. Similarly, angle C equal to 90 degree. Now, if you don't go the proof directly, you are having this one. So, how many right angle you are getting? One is angle A and another one is angle C, right? So you are getting two angles right angle here. So now we will use the previous concept. Now angle A we have to divide in two ways. If you are using here x means what will happen here? 90 minus x. Or we can use above, that is first we have written here x only. There I can write 90 minus x also. Here I will go for 90 minus x, means this side it is x, right? The 90 we should divide properly. Now here what happens, it is 90 is already there, x is there, so what is the remaining angle? 90 minus x. If you consider this side a triangle, 190 came, 90 minus x came, so it is x only. Like that we can divide easily. Then we can go for the naming and proving the criteria. Now we need to prove AB square equal to BC into BD. So you can name the triangle easily, right? Which is the letter is not repeated there. A is not repeated because B is common in all the three cases. So you can identify ABC is a triangle. Similarly, ABD is a triangle. Got? So ABC is there, ABD is there. So in that, what we should write? ABD you choose first and write all the angle. Angle A, angle B, angle T. Values you write 90, 90 minus x and x. Correspondingly, you should identify the angles in triangle ABC. For A, what is the correspondence? Angle C, because that is 90 only. Now for B, B only, it is 90 minus x. Next, what is the next case? It is angle D equal to angle A, that is equal to x. So three values we got. Now what we can write? Triangle ABD is similar to triangle CBA. Now we will write the corresponding sides. AB by CB equal to BD by BA equal to AD by CA. Now AB we required because AB square. So the first ratio and the second ratio, right? So AB square equal to CB into BD. What is the second question? AC square equal to BC into DC. So identify the triangle first. So C is the common letter. So other than that, A should be given to BC. A should be given to DC, right? So we got these two triangle, and what is the next step? ABC angles or ADC angles we should write. Let us see what you written. ABC we have written. So what are the values? X, 90 minus x, 90. Here also you can see the diagram, so you can identify that where it is x is coming in ACD. ACD is a smaller side, this one only, right? So that is x means angle D, and 90 minus x means angle A, and 90 means angle C. Any two angles you can identify and you can finish. So triangle ABC similar to triangle DAC by AA criteria. Corresponding sides to be written. Where is AC is coming? Because AC square is the required one. So second and third ratio is required. So AC square equal to BC into DC. That means AC square equal to BC into DC. Hence proved. Similarly, the third question. Third question, what we need? AD square equal to BD and CD only. Now, I think you understood the criteria. So, A is not common there. So, what is the triangle we should consider? ABD, then ACD. We identified already the angles, the 90 minus xx and all. So ABD, we will list all the three angles and its values 90, 90 minus x, x. Correspondingly, we should find the angles from triangle ACD. So, angle C, angle A, angle T. Now AD where it comes? See the second ratio. Once the similarity we proved, then similarity we can use that. So corresponding sides are in the same ratio, that we can use. So we'll got AD square equal to BD into CD by using the second and a third ratio. Okay, one more question. Triangle ABC is an isosceles triangle, right angle that is C. Prove that AB square equal to 2A square on 2AC square only, right? What is the question? Prove that only this one. What is given here? A isosceles triangle is given. That means two sides are equal. Angle C is 90 degree. So, one angle is 90 degree means it's a right angle triangle. So, Pythagoras we can apply. So, what is the Pythagoras theorem? AB square equal to AC square plus BC square. But diagram if you check, AC and BC are equal. What is the property? Isosceles triangle property. So we are replacing BC with the AC square. So how many AC square we got? 2 AC square. Hence Proved. AB square equal to 2AC square. Converse of this only, it is also easy question. Triangle ABC is an isosceles triangle with AC equal to BC. Then if AB square equal to 2AC square, prove that a triangle ABC is a right angle triangle. That means the previous questions converse only. So this time what is given to us, it is an isosceles triangle also, and AB square equal to 2AC square. So first I am writing A to AB square equal to 2AC square. 2AC, how we can write? AC plus AC only, 2AC, right? 2AC square equal to AC square plus AC square. But AC and BC are equal only, right? AC and BC are equal. So we can replace with one AC square with one BC square. So here we can see AC and BC square we are replaced. So now you see AB square equal to AC square plus BC square. Now we can see that it is satisfying which theorem? Pythagoras theorem. Therefore, the given triangle is a right angle triangle. So when the question is given, you have to draw like this only because it's an isosceles triangle. Now we have proved that triangle ABC is a right angle triangle. So we can see that the diagram will be like this because it's a right angle triangle. Now which is the common letter for this side? C is the common letter. That is why C equal to 90 degree, or we can say AB is the hypotenuse. So the opposite angle to the AB equal to C only. So C is a 90 degree. Triangle ABC is an equilateral triangle of side 2A. Find each of its altitude. It is an easy question because we already learned in the lower classes. Altitude of an equilateral triangle equal to root 3 by 2a only, right? So now let us consider it is equilateral triangle of side 2a. So AD is the perpendicular. As you know that if it is an equilateral triangle, median, altitude, everything is same only. So when we go for BD and DC, D is the midpoint, right? Because it's a median. If you D is a midpoint, which property we have applied here? Median. So first we have taken the side as a 2a only. So the half the length means it is equal to a only. Now AD is a altitude as well as median also. If it is altitude, Pythagoras theorem we can apply. So AD square plus DB square equal to AB square, that is the hypotenuse for us. So substitute the values. It is BD we got a, and AB we got a 2a. That means square means we will get a 2a whole square right side, and the left side we got a square only. After the simplification, AD square we will get a 3a square. AD equal to root 3 into a only. As we know that the formula of altitude AD equal to root 3 by 2a. This is the normal formula of any altitude in equilateral triangle. Since instead of a, this question what is given here? It is 2a. So 2 will get cancelled. That is why we are getting root 3a only, right? So altitude of an equilateral triangle we got as a root 3 in the case the equilateral side equal to 2a only. One more question, let me prove. Prove that sum of the square of the sides of the rhombus equal to sum of the square of its diagonals only. Sum of the square of the sides of the rhombus means all the sides, if you take AB square, BC square, CD square, then AD square. Sum of the square of the sides equal to sum of the square of the diagonals, which is the diagonal AC square plus BD square only. So all the four squares we are adding because we know that diagonals of a rhombus perpendicularly bisect each other. That means the angle O equal to 90 degree only. So we are taking the triangle AOB. Triangle AOB, if you consider, right, what is the hypotenuse there? AB square. So AO square plus OB square. Similarly BOC, okay, similarly we can go for a BOC, we will get a, BC square. Now all these equations if we add, what will get a 2 into 2 times, you can see that AO square is there, we will get like this. We add and substitute by diagonal property. So we'll get a 2ac square plus bt square. I'll repeat one more time in the tomorrow's class because the time is less for me.